Okay, I'm going to do number 48 now, the part 1 and part 2. And for part 1, there is differential of e to the power x, of sine x, of ln x, e to the power x again, and of cos x. Then for part 2, there is root x, which you can do from number 47. E to the power x, there is sine x, cos x, a digit minus 1, another digit 1 here. And then there's ln x to the power 5. Okay, so I want to show you some of the equations or some of the common derivatives. For example, the derivative for trig functions such as cos x, this one. The derivative of cos x is minus sine x. Derivative of sine x is cos x. The derivative of tan, and we're not doing tan, so we're going to leave tan. There is sec, there's all sorts, but there's also the derivative of a to the power x, which is ax ln a. And then there's a derivative of e to the power x, which is simply e to the power x, it doesn't change. Then you also have the derivative of ln x, this one, which is 1 over x, which is the same as this ln, but the difference is that this one here can be a plus or a minus. Okay, where there's a plus or minus, it takes the plus symbol. So if you had ln minus x, that would be the same as ln x. That's what that means. Okay, but we don't have that, so we'll just leave that for now. Then the other question, I think the last one, let's have a look. The last one was ln x to the power 5. I think I'll do that one separately. First, let's do this one. So the first one is e to the power x plus 1. So that's number 48, I believe. And we have e to the power x plus 1. So if we find ddx of e to the power x plus 1, we know that derivative of e to the power x remains e to the power x, but for 1 it becomes 0, because 1 is the same as 1x to the power 0. So because x to the power 0 is equal to 1, so if you multiply 1 times 0, that all goes to 0. So that's why that just becomes 0. So that's part 1. Part 1, and the first question was this one. The second one is sine x minus ln x. So sine x minus ln x. So we do ddx of sine x minus ln x. So you just need to remember that the ddx for sine x is just cos x, and for ln x, which is here, is just 1 over x. Okay, so this becomes cos x is a minus, so it's minus 1 over x, and that's it. So you just need to remember them for the, if you have an exam, you just need to remember that. And then the third one for these is 2e to the power x minus 3 cos x. 2e to the power x minus 3 cos x. If you do ddx of 2e to the power x minus 3 cos x, you will get 2e to the power x, it doesn't change, minus 3. And for cos x, remember that cos x is minus sine x. So you're going to have a minus sine x and a minus for the minus 3, so that becomes a positive. It becomes plus sine x. And then the second part is, or says, the first one for the second part, root x minus 1/10 e to the power x. So root x, where am I? Root x minus 1/10 e to the power x. So root x minus 1/10 e to the power x. You do ddx of root x, remember is x to the power half, minus 1/10 e to the power x. So the first part is half x to the power minus half minus 1/10 e to the power x. And that's it. That's the first of the three. And then we're gonna go for the third one. The third or the second one, which basically is three brackets. Let me write this one down. Sine x minus cos x minus 1. And we copy that. Copy. Paste. Okay, so remember that ddx of sine x was minus cos x. ddx of sine x was just cos x rather. So ddx of sine x is cos x, and of cos x is minus sine x. So this is ddx of 3 sine x minus 3 cos x minus 3, because you have to put the 3 inside. So this becomes 3 cos x. This one is minus sine x, so that becomes plus 3 sine x. And that one goes to 0. So you can put cos x plus sine x. Then we might as well do the last one. And the last one is ln x to the power 5. So that's ln x to the power 5. So remember that for ln x is just 1 over x. So for ln x, which is the same as x to the power 1. So if it was x squared, it will be 2 over 5 over x. So this one is just 5 over x. ddx of ln x to the power 5 is just 5 over x. Okay, so that's it for this video.